The National Electrical Code, or NEC, serves a specific purpose, and it's crucial to understand its intention and limitations. The code is not intended as a design specification. This means it doesn't provide detailed instructions or prescriptive methods for designing electrical systems. Electrical design involves numerous factors, including load calculations, voltage drop considerations, equipment selection, and coordination studies, which fall outside the direct scope of the NEC. Qualified electrical engineers and designers are responsible for creating safe and efficient electrical systems, taking into account the specific requirements of each project. The NEC sets the minimum safety standards that the design must meet, but it doesn't replace the need for professional engineering judgment. The NEC is also not intended as an instruction manual for untrained persons. Electricity can be dangerous, and working with electrical systems requires specialized knowledge, skills, and experience. The NEC is a complex document that assumes a certain level of electrical competency. Attempting to apply the code without proper training can lead to serious injury, property damage, or even death. Only qualified electricians, technicians, and other skilled professionals should install, maintain, and repair electrical systems. These individuals have undergone extensive training and apprenticeship programs to develop the necessary expertise. It's important to emphasize that the NEC is a comprehensive set of regulations governing the safe installation of electrical wiring and equipment. It covers a wide range of topics, from general wiring methods to specific requirements for various types of occupancies and equipment. The code is updated every 3 years to reflect advancements in technology, changes in industry practices, and lessons learned from past incidents. Adherence to the NEC is essential for ensuring electrical safety and preventing hazards such as electrical shock, fires, and explosions. The NEC provides minimum requirements. It's crucial to understand that the NEC establishes minimum safety standards. In many cases, exceeding these minimums is necessary to achieve optimal performance, reliability, and energy efficiency. Design professionals should always consider the specific needs of the installation and incorporate best practices beyond the basic code requirements. The NEC is not a substitute for sound engineering judgment. While the NEC provides a framework for electrical installations, it cannot address every possible situation. Electrical design and installation often involve complex challenges that require experienced judgment and problem-solving skills. Engineers and electricians must be able to interpret the code correctly and apply it appropriately to unique circumstances. The NEC is not a static document. The electrical industry is constantly evolving, with new technologies and methods emerging regularly. The NEC is revised every 3 years to keep pace with these changes. It's essential for electrical professionals to stay up to date with the latest code requirements to ensure compliance and maintain safety. Furthermore, the NEC isn't universally adopted. While the NEC is widely used in the United States, it's not the only electrical code in existence. Other countries and regions have their own electrical codes and standards. When working on projects outside of the United States, it's important to familiarize oneself with the local regulations and ensure compliance. The NEC focuses on safety. The primary goal of the NEC is to protect people and property from electrical hazards. The code addresses a wide range of safety concerns, including shock protection, overcurrent protection, grounding, and wiring methods. By following the NEC requirements, electrical professionals can minimize the risk of accidents and ensure the safe operation of electrical systems. The NEC relies on product standards. The NEC frequently references product standards developed by organizations such as Underwriters Laboratories, or UL, and the National Electrical Manufacturers Association, or NEMA. These standards specify the performance and safety requirements for electrical equipment and components. Compliance with product standards is essential for ensuring that electrical products are suitable for their intended use and meet the necessary safety criteria. The NEC is enforced by authorities having jurisdiction. The enforcement of the NEC is typically the responsibility of local or state authorities, often referred to as the authority having jurisdiction, or ARJ. The AHA is responsible for reviewing electrical plans, conducting inspections, and ensuring that electrical installations comply with the code. It's important to work closely with the AHA throughout the design and installation process to address any questions or concerns and obtain the necessary approvals. The NEC addresses specific occupancies. The NEC contains specific requirements for various types of occupancies such as residential, commercial, industrial, and healthcare facilities. These requirements take into account the unique electrical needs and safety considerations associated with each type of occupancy. For example, healthcare facilities have stringent requirements for emergency power systems and patient care areas to ensure the safety of patients and staff. The NEC covers wiring methods. The NEC specifies the acceptable wiring methods for different types of electrical installations. Wiring methods refer to the types of cables, conduits, and other raceways used to enclose and protect electrical conductors. The NEC also specifies the installation requirements for these wiring methods, including support, spacing, and protection from physical damage. Proper selection and installation of wiring methods are essential for ensuring the long-term reliability and safety of electrical systems. The NEC addresses overcurrent protection. Overcurrent protection is a critical aspect of electrical safety. The NEC requires the use of overcurrent protective devices, such as circuit breakers and fuses, to protect electrical circuits from excessive current flow. Overcurrent can be caused by short circuits, ground faults, or overloads. When an overcurrent occurs, the protective device interrupts the circuit, preventing damage to equipment and reducing the risk of fire. The NEC specifies the appropriate size and type of overcurrent protective devices for different types of circuits and equipment. The NEC covers grounding and bonding. Grounding and bonding are essential for providing a low impedance path for fault current to return to the source. This helps to ensure that overcurrent protective devices will operate quickly and clear the fault, minimizing the risk of electrical shock. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Proper grounding and bonding are critical for protecting people and equipment from electrical hazards. The NEC addresses equipment installation. The NEC provides detailed requirements for the installation of various types of electrical equipment such as transformers, motors, generators, and appliances. These requirements cover topics such as mounting, ventilation, wiring connections, and protection from environmental factors. Proper equipment installation is essential for ensuring safe and reliable operation. The NEC is a living document. As mentioned earlier, the NEC is updated every 3 years to reflect advancements in technology and changes in industry practices. The code-making process involves a collaborative effort between electrical professionals, manufacturers, and other stakeholders. The proposed changes are reviewed and debated by various code-making panels, and public input is solicited. This ensures that the NEC remains relevant and effective in addressing the evolving challenges of the electrical industry. The NEC is available in different formats. The NEC is available in various formats including print, electronic, and online versions. The National Fire Protection Association, or NFPA, also offers training courses and resources to help electrical professionals understand and apply the code. Familiarizing oneself with the NEC and its related resources is essential for staying current with the latest requirements and best practices. The NEC is a valuable resource for electrical professionals. While the NEC is not a design specification or an instruction manual for untrained persons, it is a valuable resource for electrical professionals. The code provides a comprehensive set of safety standards that can help to prevent electrical hazards and ensure the safe operation of electrical systems. By understanding the NEC and applying it correctly, electrical professionals can contribute to a safer and more reliable electrical environment. The NEC also addresses voltage drop. Voltage drop is the decrease in voltage that occurs along an electrical conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. By following these guidelines, electrical designers can ensure that equipment receives adequate voltage and operates properly. The NEC addresses conductor sizing. The NEC specifies the minimum size of conductors required for different types of circuits and equipment. Conductor size is determined by the ampacity or current carrying capacity of the conductor. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation, and installation conditions. Proper conductor sizing is essential for preventing overheating and ensuring safe operation. The NEC addresses raceways and enclosures. Raceways and enclosures are used to protect electrical conductors from physical damage, moisture, and other environmental factors. The NEC specifies the types of raceways and enclosures that are permitted for different types of installations. The code also specifies the installation requirements for these raceways and enclosures, including support, grounding, and bonding. The NEC addresses hazardous locations. Hazardous locations are areas where flammable gases, vapors, dust, or fibers may be present in sufficient quantities to cause a fire or explosion. The NEC contains specific requirements for electrical equipment and wiring in hazardous locations. These requirements are designed to minimize the risk of ignition and prevent explosions. The NEC classifies hazardous locations into different classes and divisions based on the type and likelihood of the hazard. The NEC addresses emergency systems. Emergency systems are designed to provide power to critical loads during a power outage. The NEC contains specific requirements for emergency power systems in various types of occupancies, such as hospitals, fire stations, and high-rise buildings. These requirements cover topics such as generator sizing, transfer switches, and battery backup systems. The NEC addresses signaling systems. Signaling systems are used to transmit information such as fire alarm signals, security alarm signals, and communication signals. The NEC contains specific requirements for signaling systems, including wiring methods, overcurrent protection, and grounding. The NEC addresses swimming pools and spas. Swimming pools and spas pose unique electrical hazards due to the presence of water. The NEC contains specific requirements for electrical equipment and wiring in and around swimming pools and spas. These requirements are designed to minimize the risk of electrical shock. The NEC addresses solar photovoltaic systems. Solar photovoltaic, or PV, systems convert sunlight into electricity. The NEC contains specific requirements for the installation of solar PV systems, including wiring methods, overcurrent protection, and grounding. The NEC addresses wind power systems. Wind power systems convert wind energy into electricity. The NEC contains specific requirements for the installation of wind power systems, including wiring methods, overcurrent protection, and grounding. It is important to always refer to the latest edition of the NEC and any applicable local amendments when designing, installing, or inspecting electrical systems. The NEC is a complex and detailed document, and it is essential to have a thorough understanding of its requirements to ensure electrical safety.